let me in.
Hey folks, I'm gonna go wait about 2 more minutes and let people filter in, and then I'll begin. Okay, cool. Can you guys all hear me?
Yep.
Yep.
Okay, great. So today I'm going to give a presentation on Elixir. For those of you who don't know what Elixir is, it's another programming language. It was written by a very prominent Ruby developer. It's gotten a huge following, and it takes a very different approach to programming that I hope to show you guys really lends itself towards speed and concurrency. So some background on Elixir is that it runs on Erlang, and Erlang is a language that was invented in the 80s at Ericsson, and they used it to control telecom switches. So these are systems that need to always be up. You need to be able to update it without it going down. It serves tons of requests, and it needs to, if anything goes wrong, be able to restart itself immediately. So it was a language that was specifically geared towards what we call high availability. So one of the main differences between Elixir is that we replace the idea of objects, so a whole bunch of things hanging around, with these things called processes, and these are all these instructions that are running at the same time. WhatsApp is a company that uses Erlang, and it currently has 1 billion users and was acquired for $19 billion. And they use it. They've written a lot about it and how they're able to use it to provide a real-time service. Other major companies are using Erlang and Elixir to also provide either real-time features or in situations in which they need just high availability. The speed compares with Java and C#. I'm going to show you guys during this presentation that it is way faster than Ruby. So with Elixir and Ruby, like I said, it was written by a Rubyist, Jose Valim, and it has a lot of similarities. One of the big wins is that the web framework is almost exactly like Rails. It was written by a big Rails user. It has a model, a view, a controller. And so wrapping your head around how it works is basically the same as wrapping your head around how Rails works. The syntax is very similar. It has a lot of do end, no semicolons. It looks very much like Ruby because, again, it was written by a Rubyist. And one of the other similarities is that they both have really active communities with thousands of libraries that are growing. People are submitting new libraries all the time. There are some differences. So like I mentioned before, Ruby deals with objects and state. Elixir is functional and immutable. So what the immutability means is that you don't share state, so you can split up all the processing. So that means if you have 4 cores on a machine, you can spread all the computations out across all 4 cores, so it runs a lot faster than Ruby. Also, Elixir is compiled, whereas Ruby is an interpreted language. So that means that you compile Elixir and then you ship it. So you discover a lot of problems, or if you have problems, during compilation time as opposed to during runtime. So I think that that's a really big win with Ruby. You know, a lot of the errors that you get are based around type safety, and with a compiled language, you get to avoid a lot of that. Elixir has a built-in idea of supervision. So, there's always going to be things that are unseen. And, it's a matter of how do you recover from things that fail? And Elixir treats that as a first-class object. Ruby, we rely on a very complex network of how to handle exceptions, how to guess what exceptions will be raised. So what that translates to is, Elixir would be able to restart itself, whereas Ruby, we get a PagerDuty alert in the middle of the night. And then finally, the big difference, the last difference, is that with Elixir, you don't need any external dependencies to achieve the level of concurrency that we want. So for example, if we want to serve up, a million requests with Ruby, we need to add more servers, we need to add more power to the servers. With Elixir, a lot of that's handled out of the box, and I will show you guys that. So Elixir is a tool, and every tool has the right situation to apply it. There are times when you want to use it, there are times when you don't want to use it. And every tool comes with pros and cons. So some of the drawbacks to Elixir is that by adopting it, we will have a slower time to market for any applications that we ship that are written in Elixir. And mostly that involves around learning it and then deploying it. However, that is a one-time cost that you pay up front. So basically, training people on how to write Elixir code and then coming up with a deployment strategy is something that you deal with the very first thing that's shipped, and then nothing, on subsequent deploys. Finally, the very other drawback is the community is smaller than Ruby. Ruby is a huge community right now, and Elixir is doubling in size every year. The size of the number of people that have been going to the Elixir conference has doubled every year for the past 3 years. People are adding new libraries all the time. So, we're sort of seeing it take off in the same way that Ruby took off around the time that Rails became really popular. So that's sort of the background. But what I did was create 2 competing applications, one written in Elixir and one written in Ruby. The idea behind both of them is that you can have a variable number of users. You can have 10 users, you can have 100 users, 1,000 users, and they're all going to hit this application right here, which is going to write to the database, sort of simulating, what goes on in a normal flow, a normal application. And then they're going to keep hitting the application until some sort of background job completes. And the reason that I chose this setup is because it allows us to vary 3 different variables. So the first variable would be scaling the number of users. We can change it from 10 users to 100 users to 1,000 users. The second one is what happens if this database write takes a while. So like if we have a very large database or this is a complex operation, how does that affect Elixir, or how does it affect a Ruby application? And then finally, we can scale the number of workers. So if we have a very long background job that runs, what does it look like when we have a lot of Ruby doing that? And what does it look like when we have a lot of Elixir doing that? So the very first one, which is the number of users, we don't have any sort of block, so we're assuming that everything is going well. We scale the number of users, and then we keep the number of background workers fixed. So I will show you what that looks like. So here we're going to start up the Elixir server, and here we're going to start up the Ruby server along with a background pool in Ruby. Like I said, with Elixir, you don't need a second process. You don't need more servers to achieve the same level of asynchronicity. So if we were to run this against Ruby, we can see that it takes about half a second for 10 users. If we run it against Elixir, we should see about the same performance, about 1.5. Actually, it's about 3 times better right now. But then if we were to vary it up to 100 users, 2.21 seconds for Elixir, and for Ruby, we see 0.21. Once we get up even higher than that, I will show you guys the findings. So for 10 users, Elixir's faster. For 100 users, Ruby starts to really choke. For 200, we start to see, miles of difference. And then once we get up to 1,000 asynchronous requests, Elixir is still performing, whereas Ruby has timed out. So we can show if we were to run this with Elixir for 1,000 requests, it's hitting the server a lot. There's a lot of work going on, and the whole thing only takes about 3 seconds. If we were to do it with Ruby, we would not expect the same performance. and we've timed out. So yeah, there we go. So this is the first case in which Elixir really beats Ruby out. The second case is, what if we block in the main thread, like there is some sort of big database operation that's going on. So what we do is we keep the users fixed, we keep the background pool size fixed, but we introduce a block into the main thread. And then we run the same, we run the exact same scenario. So if we do it with Elixir, we get about 0.7 seconds. If we do it with Ruby, for every user, we tack on that extra database call. The reason for this is that Elixir is multi-threaded and can handle every request concurrently. With Ruby, we have to block for each single one, wait until it completes, and then return it to the user. Like I mentioned earlier in the presentation, what this means is to do the same thing in Ruby that we want to do in Elixir, we have to add more servers, which adds more money. And finally, the very last one is, what happens if we change the number of, if we introduce a block and call into a background job? So like, let's say there's a network call that we need to make. How does Ruby perform to Elixir? And for this, we should expect to see that they are about the same, because all we have to do for Ruby is add more workers to the pool. Oops, sorry guys. So what we're doing here is we're just throwing more workers at the pool. And we get about a performance time for Ruby of 3.17 seconds, and for Elixir of 2.88. So they basically perform about the same. However, the caveat to that is you can only add so many background workers before you start running into a performance hit in Ruby, whereas Elixir, you can throw as many background workers at it as you can. Basically, you could not spawn enough processes in a web application to cause Elixir to choke. So for very few workers, they scale about the same, or they perform about the same. But once you get into very performance-heavy code, again, you're going to want to choose Elixir. So that leads me to my last slide, which is, again, when do we want to use Elixir? It's not for every use case, but it is for certain use cases definitely a way better tool than Ruby. And those cases are when you have a lot of traffic, if you need to leverage all cores, if you want to have deploys that don't have any downtime, if you have distributed code that all needs to work together. And the two that I think are most important for PhishMe are for services that you want to be highly available. For example, landing that has tons and tons and tons of people hitting it all the time, or services that depend very much on being asynchronous. For example, email generation. We don't want sending out 1 million emails to create a bottleneck. We want to be able to do all these things at once. Or long-running jobs that interfere with the normal application, such as screenshots. And both of these have been problems resulting in PagerDuty notifications recently, both of which could be solved by switching over to Elixir for these services. So I think that was the presentation that I have. Can I take any questions?
No questions, but that was awesome. Thank you.
I've got a question. When it compiles, does it compile into an interpreted code like Java, or does it compile down to machine code?
It compiles down to Erlang bytecode. So like Java, it runs that code natively in the virtual machine.
Okay.
Does Elixir have a well-developed testing framework?
Yes, it does.
I got here super late. By landing, did you mean like a landing page?
Yeah, so landing is part of the simulator application where if you click on a phishing link, that's where it takes you.
Does Elixir have like an interactive mode like IRB for Ruby?
It absolutely does, and it combines it into the application itself. So now we have insight into all of the processes running. So, and what's really cool is we have a GUI for it. So if we fire this up, we can see all of the running processes, how much memory they're taking up, what messages they're passing to each other. The tooling for this language is incredible. It's basically 30 years worth of tooling for things that fit the use case that I think that we're going for.
Is there an easy, I guess, an easy place to get started with looking at something like Phoenix online? Do they have any kind of good resources that you can link to?
Absolutely. I will follow up with you after. The website for Phoenix has excellent documentation on getting going.
Can you just put those links in the Lunch and Learn?
Sure.
Cool. Thank you.
And I'm not sure if it's worth mentioning, but Michael runs the Elixir group, or at least we've been doing Elixir. I don't know if that's worth mentioning for learning purposes.
Yeah, that's right. Thanks, Sean.
Yeah, it's a language that has a lot of interest in the Ruby community. So a bunch of us have been, meeting for, quick little things here and there to look into it. So we have a bunch of us have some interest in.
Yeah, so this has been Woodall talking. I think one of the reasons that I really wanted to see Michael work on this and kind of give this presentation is that we have had a few bottlenecks with Ruby. I don't think we have that use case where it's like, we've outgrown it specifically. But I think it would be interesting to sort of look at, I would say Elixir is sort of maybe our next go-to language for maybe our next microservices that we have, or at least something that we know, or, we can get out of some of these bottlenecks that we have for like email generation, or kind of like he mentioned, like this week has been crazy. Actually, these past 2 weeks have been crazy with background screenshot jobs. So moving on to something like this, I think would be, pretty helpful. And I think something that we should definitely look into in the future.
Yeah, I agree. That's a really good use case. Right now we're using Phantom.js, and we've had all kinds of problems with it, and it's ridiculously hard to debug.
Yeah, thanks for bringing that up, Ben.
Yeah, it was a great presentation. I really appreciate you putting all the work into this and building that application as well. So, yeah, thanks a lot.
Yeah, my pleasure.
Great slides.
Cool. Okay, if there aren't any last questions, then I will put all of the resources up in Slack. And yeah, thanks so much for coming and listening to it.
All right, thank you.
Thanks.
Yep, thanks, Michael.
Thanks. Good job.